In today's episode, we will look into the divisibility of numbers. Divisibility of numbers can be used in various scenarios. It will very easily and quickly help you figure out if two numbers are correlated in whichever way. This could, if you think creatively, this could be used in lots of places. For example, let's say you have to find out a series of a number, and the series of a number is in, let's say, multiples of 8. So if you know the divisibility rules, you will be able to probably quickly figure out that series, and you could think about n number of ways of utilizing this. This is a very nifty tip. So let's start with divisibility of numbers. The first number what we're going to see is divisibility by 2. For a number to be divisible by 2, the last digit of that particular number has to be an even number. So in this example, let's look at 32. The last digit of the number here is 2, which is an even number, which means this number is divisible by the complete number. 32 is divisible by 2. If we take this number, 8 is the last digit, which is excuse me, 8 is the last digit, which is an even number again, so the complete number will be divisible by 2. Here in this example, 9, which is an odd number, is not divisible by 2, hence this number is not divisible by 2. If we take this example again, this is an even number, which means this complete number is divisible by 2 again. Now let us check out the divisibility rule for 3. Divisibility rule for 3 is very simple. You need to add all the numbers or all the digits of a particular number, and if the sum what you get out after this addition is divisible by 3, then the complete number is divisible by 3. What I mean to say is, you add 2 plus 2 plus 2, which is 2 plus 2 is 4, and 4 plus 2 is 6. Now 6 is divisible by 3, hence this number will be divisible by 3. Okay, we'll do another example. 1 plus 9, it's 10. 10 plus 9 is 19. 19 plus 2 is 21. 21 is divisible by 3, hence this number is divisible by 3 again. Let's do this example now. 6 plus 7 is 13. 13 plus 4 is 17. 17 is not divisible by 3, hence this number is not divisible by 3. I hope you're getting the idea of it. Divisibility of 4 depends on two rules. First rule is the last two digits of any given number. If it is divisible by 4, then the complete number is divisible by 4. Here the last two numbers are 24, and 24 is very well divisible by 4, hence this complete number is divisible by 4. The other rule is, if the last two digits of a given number is 0 and 0, then that number is also divisible by 4. So you need to remember two rules here, that is the last two digits is divisible by 4, and the last two digits are 0 and 0, then these two conditions are met. Divisibility by 5 is pretty simple. If the number ends with 5 or if it ends with 0, then this number is divisible by 5. Very simple. Divisibility of 6. So divisibility by 6 is very simple again. Now take a number. If this number is divisible by 2 and if it is divisible by 3, see, it's and here, so both the conditions have to be met. If it is divisible by 2, if a given number is divisible by 2, and if it is divisible by 3, then the complete number will be divisible by 2. So we know the divisibility rule for 2. The divisibility rule for 2 says that if the last number is an even number, which is the case here, then that particular number will be divisible by 2. So yes, this meets the first condition. It does meet now the second condition is, if the number, we have to check if the number is divisible by 3. So we know the divisibility rule for 3. We need to add all the digits of the number. So 8 plus 1 is 9. 9 plus 7 is 16. 16 plus 2 is 18. 0 we are not adding here, no value. So the complete sum of all the digits is 18, and we see if 18 is divisible by 3. Yes, 18 is divisible by 3, so the second condition is also met. So we can safely assume that this number is divisible by 6. Divisibility by 8. Divisibility by 8 is also pretty simple. Here again we have two rules or two different criteria through which we can find out. We check the last three digits here in this case, the last three digits, and if the last three digits is divisible by 8, then the complete number will be divisible by 8. In this case it is 656. You check if it is divisible by 8. 8 goes 8 times 64, and then 16 goes 2 times by 8, so 82. This number is divisible by 8, hence this complete number will be divisible by 8. And the next condition is 000 at the end. If it is 000 at the end, then also the given number will be divisible by 8. So here we need to know either this condition works fine or this condition works fine. Whichever condition works fine, the number will be divisible by 8. Divisibility rule of 9 is simple again. We add all the numbers, all the digits of a particular number, and then see if that added sum is divisible by 9. If it is, then the number is also divisible by 9. So here in our case it is 6 plus 0, 6 plus 6 is 12 plus another 6 is 18. The sum of all the digits is 18. If we check if 18 is divisible by 9, of course it is divisible, so this complete number is divisible by 9. Divisibility by 10 is the easiest. If number ends with a 0, then the number is divisible by 10. Divisibility by 11 is a pretty interesting case. What we do here is we identify the numbers which are we identify the digits which are in odd places and even places. We get the sum of the digits which are in of these numbers, and we subtract them. And if the end result is either divisible by 11 or if it is 0, then we consider that number to be divisible by 11. So let me write it down here again. First step is we identify the numbers which are there in odd places. So it is always from the left side again when we are identifying it. So first what we do is we take the sum of digits of numbers in odd places and then subtract this with sum of digits in even places, then we get some result. Okay, we get a result. If this result is either divisible by 11 or if it is 0, then the number will be divisible by 4. Now let's do this by example. Identify the digits in odd places. The 1, 9 and 4 are the digits in odd places. We take the sum of them. 9 plus 1 is 10, 10 plus 4 is 14, and then we identify the digits which are there in even places, that is 0 and 3. We add these two, that is 3. We subtract 3 from 14. The end result is 11. 11 is divisible by 11, and hence this number is again divisible by 11. It's that simple. Next we take this example. In this example, 9, 1, 2 are the 9, 1, 2 and 0 are the numbers which are then in odd places. We add them. 9 plus 1 is 10, 10 plus 2 is 12. Now numbers in even places or digits in even places are 6, 0 and 6. We add them, we get 12 again, so we subtract them and the answer is 0. So again, as we had already said, there are two basic conditions. Either it should be a multiple of 11 or 0. So the second condition satisfies this, and this number is also divisible by 11. So this is pretty simple. You need to go through this video a couple of times. It is pretty simple, fairly very easy. Once you get an idea of what exactly is happening and how to do this, you will be able to quickly identify the the numbers which are divisible by other numbers. Very helpful in computing bigger problems. Thank you.